form of a string. And you can see here that I've just used the character R. If I do that, then what the language understands is that what I'm looking for is just a red line. R is always for red when you're plotting. And again, I'm labeling the axes and I'm showing the plot. And here I just have a straight red line, where before I had a straight blue line. Now, if I want to do symbols instead of a line, what I can do is, in this additional argument, here I'm specifying the line, but I'm also specifying the line or marker type. In this case, I'm saying use stars. And so what I get are green stars not connected by a line if I use the argument that way. Let's say that I can do different symbols too. If I don't want to do stars, I could do little circles. In that case, that would be represented by just an O. That's not a 0, it's a lowercase o in this case. And now I'm getting magenta circles. I have hopefully something prettier. Yeah, okay, cool. So this uses a little bit more keywords and it's a little bit more programming, but I get a more interesting plot out of this one. So what I want is I want square markers that are this aquamarine or kind of teal color, and I want those outlined in orange, and I want the line to be a dash dot line that is orange. So that's going to be a little, we have to think about that, right? So what I'm saying here in this plot statement is that I want to plot my X and Y data against each other. I would like to use squares for that. I would like to use this RGB color. So an RGB color is what's called a tuple, or 3 comma separated values surrounded by parentheses. And what I have is my value for red, my value for green, and my value for blue. So this varies from 0 to 1, so the percentage, basically the overall percentage of the intensity of that color value that's going to feed into making the overall color. So in this case, this is the RGB representation for this orange color that you see. It has a lot of red, it has some green, and it has no blue in it. And you can just Google, RGB codes, and you can pull out codes that way. Sometimes for those RGB generators, so sometimes RGB values are scaled between 0 and 255. Python expects those values to be scaled between 0 and 1. So if you look up values and they're between 0 and 255, just divide all your values by 255 to scale it between 0 and 1. And that's the simple conversion that you can do. So now I'm also adding an additional argument where I'm letting matplotlib know that what I would like is, instead of a solid line or no line, I would like to have this dash dot line. And then additionally, I want the face of the markers to have a different color. And so you can also use, matplotlib responds to, I think they're called IKCD color codes. Do you guys know what IKCD is? It's that web comic. Anyway, it's a popular web comic. I'll put maybe a couple in a presentation sometime. It's a very programmy nerdy thing to do. But anyway, they have a lot of actual character color codes that have been predefined with RGB values. So you can use those as well. And I think I have one more example using some other color codes. Yeah. So in this case, what I wanted was, I wanted to have this dotted yellow line connected by yellow triangles that have blue outlines on them. So here I've supplied the color code not as an RGB code, but in this case this is called a hexadecimal code. And a hexadecimal code is a base 16 number code, number and letter code or character code that specifies the intensity of an RGB value. So in this case, I'm specifying that I have a full intensity of my R color, medium intensity of my green color, and very low intensity of my, or I think high intensity of my blue color, I think is the way that works. But again, you can Google these, just Google hexadecimal color code, and you can pull those up pretty easily. And then I've just said to make the marker edge color blue in this case. So those are just some simple plotting examples for plotting 2D data, and it's a really good idea to just have you know, a basic, you know, plotting example that you can copy and code between, or excuse me, copy and paste between different scripts that you're writing, and be able to just edit it a little bit to get a standard plot out. I will show you guys just one more example, and this is probably something that would be better to go over on your own and step through, but that USGS file, let me open this up really quickly. So I showed you guys in that presentation earlier a text file from USGS, and so I've loaded that text file here, and I've written a script for you guys to be able to read this file. So remember when we talked about looking at the different parts of this file and how we have to communicate to Python which parts of this are data that we actually want to read in and which parts are not. These USGS files are actually pretty problematic because they have a lot of little oddities in them. So for example, we have this big header with comment characters that needs to be ignored. That's followed by a line of column headers. And what I didn't talk about before is that USGS has an additional format line beneath the column headers. And what this lets you know is that it lets you know the width of each column and the type, the data type for that column. And this is kind of a programming artifact from Fortran, from people who used to use more interpreted languages as opposed to compiled languages. And so it used to be very important to specify the type and width of each column. That's a little bit of a holdover, but it is something that we still need to be aware of when reading in this file. So when reading in this file, what we want to do is we want to tell the computer, skip over any line that begins with this character, which we're going to refer to as our comment character. Read in the following line of data as column headers, skip the formatting line, and then read in everything, read in everything below that as data. And so Python has a couple of data analysis packages that are very popular. They're called pandas and numpy. And so I have examples of how to read files in this document using those. But the first example that I show is how to do this quote unquote the hard way, which would be reading it line by line. So when you use different programming languages, there are different, special packages or tools that make reading and writing files very easy. But sometimes either those particular tools won't work for a more challenging file to read in, or you may be new to the language and may not have those skills developed yet. So it's a really good idea, I think, to learn how to read and write data by manually looking through each line of a file. And searching for the pieces of information that you need. So I'm not going to go over this example line by line because I got to tell you, I've tried that before, and I didn't have a lot of happy programmers at the end of it. So this will be a go through on your own time if you are interested. But what this script does, I have, again, an implementation algorithm, is it opens files for reading and writing. It reads in the input file line by line. It checks to see if that file begins with $, or the comment character, and skips over it if that is true. So that would be a conditional statement. Then reading in an entire line and splitting it along a delimiter. Searching for an appropriate code. USGS uses A would be the code for data that has been accepted for publication. P would be provisional data. I believe that data is provisional until it's gone through, I think, 90 days of review, but it could be longer than that. I might be wrong. And then I think what am I doing here? Oh, I'm making sure that I have the correct, criteria. I'm making sure that it is a value from USGS and not from some other agency. And then I'm writing that data string to an output file. So you can see that the code to do that is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, probably about 20 to 30 lines, or not 30, but probably about 20, 25 lines long, which isn't horrible, but I have then a couple of examples of how to read that data in using NumPy, which would be, let's see, this is 1, 2, 3, 4 lines of code, or not even 3 lines of code. To do it with pandas is, again, a very small amount of code, and there are functions that I can use here. So for example, with pandas here, I'm using this read CSV function. I'm passing in the first argument is going to be the name of the file that I'm reading in. I can specify, if I want, I can specify the data type of each column. I let it know the delimiter of my file. So in this case, it's a tab delimited text file. I let it know to skip the first 38 rows, I think. I let it know that the column headers are in row, well, the row with index 37, which because Python is zero-based, is actual row 38 here in my file. And then I'm letting it know the only columns that I want to read in are column indices 2, 7, and 8, which would actually be columns 3, 8, and 9, right? The 3rd, 8th, and 9th columns, but these are the index locations. And so what this script does is it will do each of those, read the same file in 3 different ways, and it'll write an output file in 3 different ways. And ideally, those output files are all identical. If they're not, then I messed something up in the code when I pushed it over to Git, and then we have a problem. But but it should work. It really should work. So those are the demos that I had kind of prepped to show you guys today, and then I guess we can open up the rest of this time to discussion, or if you guys have any questions or you want to talk about individual applications, now I guess would be a good time to do it. But if not, then we can also wrap up. Yeah. Not a problem. Thank you very much for coming. So yeah, I guess I'll say thank you, and thank you so much for coming. I hope to see you guys on the 15th in a couple weeks. But yeah, feel free to get in touch with me anytime. Awesome. Thank you. Cool.